about what embodied AI might be. For people who aren't that interested in embodied AI, they might try to dismiss it and say, okay, embodied AI, that's just robotics. Symbolic AI is usually connected up with rationality. And so once you make that admission, you can either then just ignore it, or you can take it seriously and say, okay, well then our artificially intelligent systems can't be exhausted by their symbolic reasoning components, but they must be built on some kind of, I'll say it, foundation.
Hi everyone, welcome to the first episode of the Embodied AI Podcast. You just heard the voice of Dr. Ron Chrisley. Ron is a professor of cognitive science and AI at the University of Sussex. He's the director of the Center for Cognitive Science and also works in the Secular Center for Consciousness Science. Currently he's on extended leave as he's a co-founder of an AI startup in Silicon Valley. This first episode is all about setting the scene for the podcast. Ron introduces Embodied AI by discussing some key people that inspired his career path from Stanford to Sussex and lays out 4 dimensions to think about it. We delve into AI history and symbolic AI and go into detail on his 2003 paper where he makes a case for embodied AI by making reference to the ideas of Lewis Carroll and Ludwig Wittgenstein. We also link this to current machine learning. Next we talk about his work on non-conceptual content and finish off with some really interesting ideas Ron has on AI creativity and some career advice for younger listeners. If you want to jump ahead to specific questions, there are timestamps in the description. Hi Ron, it's great to have you here. How did you get into AI? What is your background?
Well, first let me just say thank you very much for inviting me to be not only on your podcast, but as the first guest for what promises to be a very exciting podcast series that I will follow with interest. My background. So I have a pretty interdisciplinary background, and that probably goes back to at least my undergraduate days, because I didn't. My major, it was at a U.S. university, at Stanford University, and my major, as they call them in the U.S., wasn't a single discipline. I was interested in too many things. I mean, my world just expanded and exploded open when I arrived at Stanford. So I just wanted to study everything and major in everything, but I couldn't. But there was a cluster of issues that I was interested in, and fortunately, there was a degree program at the time. I won't go through all the details, but I'll just say I ended up graduating in what was called symbolic systems. And I think I was the first graduate of the symbolic systems program. I was at least in the first year of graduates. And that's a program that's gone on to be very successful at Stanford. And it's due to that interdisciplinary experience there that I've maintained a kind of interdisciplinary interest in areas having to do with the mind and artificial intelligence and philosophy and logic and things like that. That's when I first got interested in AI, where I first heard of artificial intelligence as a discipline and cognitive science as a discipline was at Stanford. And my first job, well, of course I had jobs in high school, pumping gas or clearing tables. But I mean, my first job while I was an undergraduate, first real job was as an AI programmer. And that was many decades ago. And so it's continued on from there, this multidisciplinary interest, meaning that that was a bachelor's of science degree at Stanford that included computer science and linguistics and philosophy and logic and psychology. And in my case, digital signal processing and computer music. But then I also did a DPhil or a PhD at the University of Oxford in philosophy. So not just sticking with the technical subjects, but I decided for my postgraduate studies to do some serious philosophical work. And in between, I had a Fulbright grant to work on neural networks do research on neural networks with the unfortunately recently departed Teuvo Kohonen, who was a pioneer in neural networks and who really was responsible for getting my machine learning career off to a great start. But, since then, I've been working in cognitive science, directing the Cognitive Science Center at Sussex, and collaborating with psychologists on empirical studies, but also doing a lot of theoretical and philosophical work. So a very varied background, a very interdisciplinary background. And what got me into, I think if I had to point to one event that got me into AI, it's a bit cliche for people of my generation, but it's true. The book Gödel, Escher, Bach really excited me, and I found it to be a delightful book that by Douglas Hofstadter. It was a book that really opened my eyes to looking at the mind and computation in a different way. So I have my friend to this day, Avery Wang, to thank for giving me a copy of that book and encouraging me to read it. And that plus the environment at Stanford really meant that I never looked back once I got an interest in AI then.
That sounds awesome. The symbolic systems at Stanford. That sounds so good. It's something maybe I should have done, if I'm being honest. And Gödel, Escher, and Bach is a book I actually just bought 2 weeks ago. So I'm looking forward to that. So we are on a podcast about embodied AI, and we should probably start off with the question, well, what is embodied AI? I kind of want to leave this open-ended from my side. I don't want to give a definition. So if we have future guests, I'm happy for them to have different perspectives on it. But we have you here. You have written about embodied AI in 2003 in a paper, which we'll talk about later. And this fits in sort of to the history of AI. You say that it sort of stands in opposition to symbolic AI and GOFAI, good old-fashioned AI. Could you unpack this for us?
Yeah, so what I'll do is let me bridge from that biographical introduction to the topic of embodied AI, because there's a way to do that. So so I first got interested in symbolic AI through my first AI programming jobs, which were in symbolic AI, what were then called intelligent tutoring systems. Now you'd call it computer assisted learning or something like that. That was my very first AI programming job. It was very much traditional symbolic AI. I was working with a researcher named Derek Sleeman, and that was the predominant, working with expert systems at NASA, things like that. That was the dominant approach at the time. But the move to a more embodied approach had two. I guess there were two events that I could point to that really, that stand out as helping me make that transition. And one was Douglas Hofstadter again. So he wrote a paper called "Waking Up from the Boolean Dream." And after reading Gödel, Escher, Bach, I was reading his other books and following his other writings. And this paper really convinced me that an austere symbolic approach to AI was inadequate. And that, combined with there was Terry Sejnowski and other connectionists were the machine learning people who were then called connectionists, were doing the lecture circuit and ended up at Stanford, and Terry gave a talk that demonstrated the success of his machine learning system that learned how to pronounce, how to do text to speech, basically, without being programmed explicitly. It just learned how to pronounce English text with a much higher intelligibility rate and in much fewer person hours than the standard rule-based, symbolic system-based AI system at the time. And that was really quite an experience, because he had a great demo where he actually played audio recordings of the system pronouncing English text at various stages of its learning development. So initially, it's just a random selection of phonemes, like babbling. And then there gets to be a point where it learns that a space in the text means don't say anything. So it learns to segment. And then it learns to have roughly vowel consonant alternation, or at least it learns the distinction between vowels and consonants. So it sounds even more like a baby kind of learning how to speak. And then eventually the intelligibility gets higher and higher till it gets to a very high point indeed. So that recording was is an example of how having not only good science or good technology, but also a great demo can really influence maybe a generation, but at least influence young researchers. And it certainly influenced me. And one last name I have to mention was Terry Winograd, who was at one time he was the enfant terrible of symbolic AI with his Sherdlu Bloxworld program that's often mentioned in AI textbooks now. But then he turned his back on that approach, and in effect, really turned his back on AI altogether because of what he saw were the limitations of the symbolic approach. So I took a course from him. I took his course on natural language processing, which is just straightforward technology, straightforward, computer science class. But I also took a more philosophical class by him called, I think it's something like Phenomenological Critique of Artificial Intelligence or something like that, which was he was giving that. He would later publish a book in, I guess it's I think it's Fernando Flores. I hope I've got it. Anyway, they co-authored a book called Understanding Computers and Cognition, and the notes for our class would eventually become that textbook. And that really opened my eyes to some limitations of the symbolic approach. But also, to be fair, he had someone come in to suggest alternative approaches to doing AI that might overcome those problems. And Paul Rosenblum was a guest lecturer in that class, and he introduced us to connectionism and why it might be thought to have be a way to overcome the problems of symbolic AI that Winograd was identifying, and that really influenced me as well. So I think I made a move to neural networks, machine learning, connectionism while an undergraduate, and that was in part a move towards embodied AI. Even though it's possible to do neural networks and do machine learning in a very non-embodied way, as I think we could still see in today's practice, nevertheless, the reasons that I was moving towards neural networks was mainly to try and address some of these problems in the disembodied nature of symbolic AI as it was done at that time. And that led me to get an internship at Xerox PARC. And it was a great environment. There were people like Brian Cantwell-Smith, who I might mention his work later on, if I hope, because he was understanding not only that AI, it wasn't really focused on AI. He was basically seeing how computation itself should probably best be understood as an embodied activity, and that you can get pretty far trying to understand computation without reference to embodiment. But really, if you want to understand what makes computation so successful in the broadest terms, and if you want to understand computational practice, you'll have to pay attention to more than what is usually taught in purely mathematical approaches to computation. Also at PARC at that time was a then young philosopher named Adrian Cousins, who influenced me so much that when he returned to Oxford after my undergraduate degree was over, I then, after doing that Fulbright with Cohonen, decided to go to Oxford, not just because he was there and I wanted to learn more from him, but he was a large reason why I chose Oxford as opposed to, say, MIT, where I also had an offer to do a PhD. Lucy Suchman was also there. I don't have time to go into her approach, but it was very much an embodied approach to activity and planning and action. And Phil Agri as well was there. And it was just a great environment to think about the role of factors that according to the symbolic approach are just mere implementation detail or somehow external to the to intelligence or to the computational process, where actually understanding them in a way that sees them as very constitutive of what makes successful systems really work in the real world. That set of issues kind of gives you an idea about what embodied AI might mean for me. It's in a very general way. It has, if I was to state it very generally, I'd just say it's an approach to doing AI or understanding what the task of AI is that emphasizes the role that the body, whatever that is, but let's just leave that as a placeholder right now, the role that the body plays in intelligence, say, or in intelligent activity, or whatever it is you're talking about. So it's true that there are many different views about what embodied AI might be and what it might look like. Like, for instance, for people who aren't that interested in embodied AI, they might try to dismiss it and say, okay, embodied AI, that's just robotics. So anytime you have robots on the scene, you're doing embodied AI. And I guess trivially, maybe also you'd say anytime you're doing AI that doesn't involve robotics, then you're not doing embodied AI. I think that robots are very important to at least certain kinds of embodied AI, but I think that understanding of what embodied AI is just too simplistic. It misses a kind of range of issues or depth of issues that are more illuminating if you're trying to understand all the points that embodied AI researchers are trying to make. So maybe I'll just offer 4 dimensions concerning embodied AI that might, just mentioning these 4 dimensions and the fact that there are varied positions along each of these dimensions kind of might give you and your listeners an idea about how rich the area of embodied AI might be and how there are strong radical differences within embodied AI about what embodied AI is. So the first dimension, obviously, I guess, is about that placeholder I mentioned, the body. When we're talking about embodied AI, the body is involved somehow, but what kind of body? Do you mean a body that's just like the human body, that is a humanoid body, with 2 eyes and limbs and maybe a physiology like ours, or is the notion of body in play here something that is just as concrete? I don't want to say it's more abstract, but it's just as concrete, but it allows for variations in the kind of body we're talking about. So it doesn't have to be a human body, perhaps, that is playing the role of in embodied AI. It might be a non-human body. It might even be a body unlike any existing living form that we know now. It might be a body that isn't even alive. Maybe it's like a robotic body, which isn't alive in standard senses of what life means. To the extreme, to a kind of extreme where you see this in some of my work, where by body I just mean some kind of locus of perception and action that's in the world, that has causal interaction with the world. So that's the kind of minimal approach to embodiment that I think you get to when you're just trying to find an alternative to the symbolic approach. The disembodied symbolic approach just considers intelligence to be computing some function, and it doesn't make any reference to, well, who or what is computing this function, and in what kind of an environment are they, and what kind of aspects does this agent have other than computational aspects, and what are the purposes of this agent, and what kind of physical and temporal characteristics does this agent have? I mean, those aspects tend to be neglected in disembodied symbolic AI. So you could even be doing embodied AI just as long as you insist on there being an actual physically realized agent, even if it doesn't have a body in any sense of it being a living body, or it being or like any organisms that exist now. It might be an artificial body. So in that sense, I come at this from a different direction. Even though I've co-authored papers with Tom Zimke, there is this researcher, Tom Zimke, and another colleague of mine, Tom Fröse, who've written an amazing paper on embodied AI, and I hope you get one or both of them as future speakers in your series. They've written a really successful, widely read paper on embodied artificial intelligence, where they sketch out their view of what embodied AI would have to be. That's different from mine, in that they think, bodies to really be intelligent, something has to have a living body, because if it doesn't have a living body, then it doesn't really have any purposes or meaning of its own. And so it couldn't possibly, for something to be intelligent, it has to, or truly or intelligent have to have intelligence of a certain kind. For something to be autonomously intelligent, it has to be, as far as I understand their position, it has to be, on their view, alive, and therefore in the world in the same way we are in the world, not something that is giving meaning and purpose from an outside perspective that's being merely attributed to it. All our computers today, they would say, merely appear to have meaning and appear to do computations or appear to have intelligence because we decide that we attribute to them, to their states, different meanings and purposes. But if you want true intelligence, they would argue, it has to be something that has those purposes and meanings non-derivatively, not because of an external subject attributing it to it, but because of its very nature. And they think you can only have that if you are alive in a roughly, in the sense, more or less like that put forward by Francisco Varela. So I just wanted to point that out, that my notion of embodiment is quite weak compared to some people in this field. So that first dimension is what kind of body, and there's a wide range of disagreement on that. But moving on from that is the question about, well, what about this body? What's the claim of embodied AI? Some might say, unless you have a body of some sort or other, then certain kinds of intelligence will be impossible for you. So it's a necessity claim. But not everybody. Some might say, well, a disembodied system could perhaps be intelligent in this or that way, but our intelligence is not like that. Or if you're going to try to make something that's intelligent, maybe an embodied intelligence will be the most natural way or the easiest way to do that. Or maybe if you're designing artificially intelligent systems, maybe it's a good tool in your toolbox to have the embodied approach, because it can save you. It can be more efficient. An embodied solution to certain problems can be more efficient or more, less energy consuming than other approaches. Like a passive robotic walker hardly consumes any energy, as opposed to a symbolically driven walker like Honda's Asimo, for example. So there's that dimension of variation too. Is it a matter of necessity, or is it a matter of pragmatics, or say explanation of natural systems that you're talking about when you talk about embodied AI? A third dimension is I sort of got onto already in that second dimension. A third dimension is the science versus the technology. So are you interested in doing AI in order to understand natural systems and in order to copy as well as you can the abilities of natural systems like humans? Or are you just mainly interested in technology and in designing systems that have certain kinds of pragmatic value, and that if where you are on that spectrum will change the kinds of embodiment that might be of interest to you? So that's something to keep in mind when thinking about these things or reading what people are saying about embodied AI. You have to have a good idea about where they're coming from in terms of whether they're really trying to be faithful to a particular naturally embodied system like human or a fish, or whether they are just interested in achieving some technological functionality and don't really care whether it matches up to something natural. And then finally, the fourth dimension would be, what is it that we're talking about is it embodied intelligence? Is it embodied cognition, consciousness, emotion? It might be that some of these require a certain kind of embodiment or not, whereas the other ones differ. So it might be that consciousness requires a strong kind of embodiment. Maybe even the conscious system has to be a living system in the sense of Zimke and Fröse, but intelligence doesn't, or cognition in general doesn't. Or it might be that emotion is essentially embodied. You can't have any emotional states unless you have some kind of system, some kind of body that has a hormonal response or has viscera or something like that. Even though it might be possible to have purely cognitive states and to be intelligent in a purely functional sense without a body. So that's the fourth dimension that I wanted to mention, that I hope when you put all those four dimensions together, try to do that in your mind, you get an idea of like, oh, there's quite a wide range of different possible positions and methodologies that are possible here.
Yeah, that four dimension, that's a lot to unpack in this podcast. On the passive dynamic worker side, actually, I'm really hoping to get Barbara Webb from Edinburgh for the next episode. So we'll talk more about that if I get her. And
no, she's great. She's been thinking about these things for a very long time and has a lot of a lot of practical and insightful things to say about the role of the body in different. About, for instance, I mean, the famous example that I teach in my classes is cricket phonotaxis, but a lot more than that besides too.
On the meaning side of things with Tom Zienke and Tom Frese, I hope we will talk in a second about the relevance problem, and I think that's slightly connected, but also I wanted to step back and talk about symbolic AI again, because I think lots of listeners might be a bit younger, maybe my age, and symbolic AI in the 70s, that might be a bit far away. It might also be quite an abstract term. And you mentioned that your supervisor, Terry Winograd's, his program, Shrewdloo, is often used in textbooks as like a textbook example. And that would be maybe actually a good example to unpack for us, so we have an example of symbolic AI and maybe can link it to language and maybe embodiment.
Yeah, sure. So yeah, just to give a quick sketch of the symbolic approach. I mean, I guess it comes from research, like think of the earliest AI researchers, like the Dartmouth conference that started up AI as a discipline back in whatever it was, 56 or something like that. You have people like Marvin Minsky and Alan Newell and Herbert Simon, and Newell and Simon in particular had maybe they got to a symbolic understanding of intelligence by maybe they were introspecting quite a bit. So they basically thought, what do I do? What steps do I go through when I solve a problem? And they would just introspect and say, well, I mean, in the way that you or I would, if we were trying to reason about once we start reflecting on how we do things and how we use our mind, rather than just me giving you a division problem, I ask you to think about, well, what are you doing when you do a division problem? You'll say, well, I start with this state and then I transform it in this way. I start with this hypothesis about what the solution is, and then I perform this operation. I check to see whether the number that I've guessed multiplied by the divisor actually is less than or greater than the number to be divided. And you could start going through all the steps you go through and then write these down and maybe make a flow chart out of them. Maybe that's how a lot of people do programming, as they think about, well, if I were a person confronting this computational task, what would I do? And you just write down the steps. And programming languages are a great way of just converting those steps into recipes or into more than recipes, control structures that make computers do things. So there's this instant translation from a description of the process to the process itself. But that's very so the idea is that intelligence would just be a matter of, take the case of Shrewdloo, it's intelligence happens once I have a set of symbols that represent the way the world is, like where the blocks, what the positions of the blocks are, and what are their shapes and their colors. Then intelligence takes those representations and manipulates them according to a set of rules. Like if the goal is to have a red cube on a blue rectangle, or whatever it is, have a red pyramid on a blue cube, then look for a red rectangle, a red pyramid, and then look for a blue cube and lift one up, put on the other, all that. And then the output would just be a symbolic specification of what action should be done. And then the symbolic view was, that's it. That's intelligence. It was a transformation from input symbols, which represent the state of the world, to output symbols, which represent actions to be performed in that world. And you can get pretty far with that in certain domains, but if you try to take that approach to acting in the real world and doing the kinds of things that humans try to do, there are a lot of things. It seems that there are a lot of kinds of intelligence that, even though it seems like they should be capturable in that way, turn out to be elusive. It just is not a really good way to no. There are lots of things that we do, or that we think a robot or our computing system should be able to do if it's intelligent, that trying to do it that way has not been able to achieve. Setting aside intelligence, even computation maybe is best thought of as a process that isn't best understood as a transformation of symbols into other symbols. So maybe computation itself, the reason why computers are so successful at doing what they're doing, even when there's no robot involved, when it's just an airline reservation system or something, the thing that makes it successful at being an airline reservation system isn't just a matter of computing a particular mathematical function in the Turing machine sense. The best way to understand what's going on there might be in terms of a richer notion of computation, a notion of computation that we called embodied computation. That is, the slogan was that computation in this sense is in, of, and about the world. So what we meant by computation being in the world is that the computational process is a physical process that can be caused by the outside world, and it could also have causal effect on the outside world. And that this was typically richer than what could be captured just in terms of the abstract mathematical notion of input and output, because there are all kinds of, any computational process is going to have, by virtue of being in the world and having causal interaction with things, is going to, its action in that world thereby transforms its future inputs. So it's more, rather than a straight line mapping from input to output, it's more like a circle where you have, input to the computer, maybe along the top arc of the circle, you have input to the computational process causing an output, but that output on the bottom part of the circle has an arrow going back, which is transforming the world in a way that will affect the future input. So if it's a circle like that, then it's really arbitrary in some ways to draw a short boundary between the parts of the world that are doing the computation and the parts of the world that the computation is being done on or done, that aren't doing the computation. It's really parts. If once you see it that way, you see that really the world plays a role in the unfolding of the computational process in many cases. Now, I'm not saying maybe there are some strict extreme cases of computation like theorem proving or something where there's absolutely no interaction with the world, and maybe you can get by without having to have a rich notion of being in the world. But when you have an airline reservation system, quickly the fact that the system is in the world will require you to take that into account when you're theorizing about or designing your computational system. But it's not just, computation isn't just in the world, it's also of the world. That means it's made of world stuff. It's made of the very same stuff that the things it's interacting with are made of. So abstractions of computation are just that. They leave out certain details like the temporal aspects of how long a process takes, a computational process takes to do what it does. I don't just mean in numbers of steps, but I mean the actual amount of time that it elapses, or the amount of energy consumed. Notions of synchronization with outside temporal processes. Those factors are ignored when you just think of computation as an abstract function. And then finally, about the world, I don't need to spend too much time on this because I think at least traditional AI, maybe even current machine learning based AI, has not been too bad, not as not neglected so much the about the world dimension. Computation is in the world, of the world, and about the world. That's semantics. So computation is typically about something and represents things in that external world in order to coordinate better with things that it isn't actually in physical proximity to. Although I do think there's a lot that could be said about that. So I'm going to try to limit my, I'm not going to say much more about that now. So the idea was that if computation is generally in and of and about the world, then all the more strongly any computational intelligence system, like an artificial intelligence system based on computation, it's also going to be in, of, and about the world. And we should take into account all three of those factors when designing it to be intelligent. And the symbolic approach typically didn't. It didn't take into account, in particular, the fact that these systems were in the world or of the world. And that required a new way of thinking about computation, therefore thinking about intelligence realized in computation.
I don't want to go into this tangent because we'll just talk for far too long, but about being in the world, I guess the feedback you described between the agent and the environment, that links back to cybernetics, and there are probably links to embodiment and cybernetics. But let's talk about your 2003 paper about embodied artificial intelligence, and I invite all the listeners to read it. It's really interesting. What I want to focus on is something you describe as the relevance problem. It's sometimes also described as the frame problem. What is the relevance problem?
Well, yeah, in that part of the paper, I was trying to maybe give almost an a priori argument for embodied AI by saying that if you had a pure, according to our notions of symbolic AI, is usually connected up with rationality, or symbolic notion of intelligence is usually connected up with a kind of classical notion of rationality. What would the rational being do if it had these inputs and that this was its goal? Is there some rational way to try to achieve that goal given the state of the model of the world? And what I was trying to do is apply some kind of thinking that's parallel to it comes up in many different ways in cognitive science and philosophy and AI, but you can trace it back to, say, Lewis Carroll's dialogue, what the tortoise said to Achilles, what the tortoise said to Achilles. So in Zeno's paradox, there's the tortoise and Achilles. I don't have time to go over that, but Zeno used the tortoise and Achilles to prove this counterintuitive result that as long as the tortoise has a head start, it will always beat Achilles, no matter how fast Achilles runs. And then Lewis Carroll, actually publishing under the name Charles Dodgson, his real name, in the first ever issue of the venerable journal Mind back in, I don't know if it was in the late 19th century or in the early 20th century. I think it must have been the late 19th century. He published this paper about, I think it might have even been called What the Tortoise Said to Achilles. And this dialogue captures in a fun way a limitation of a purely symbolic, purely rationalist approach to, well, let me say a purely symbolic approach to rationality. So I don't have too much time to go into it here, but it's something like this. The tortoise asks Achilles, why, when we believe P and we believe P implies Q, why are we entitled to conclude Q? So deduction. Something as safe as deduction. The tortoise is wondering, why is it that we can conclude that? And Achilles says, well, isn't it kind of obvious? You've got if P then Q, and you've got P, so therefore Q. That's just what it means. So, yeah, but the tortoise says, wouldn't you have to assume that something else, that you could have P and you could have P implies Q, but you need also something else that's implicit. It seems that the assumption that when you have P and you have if P then Q, then you're entitled to deduce Q. And so Achilles says, okay, yeah, you're right. We should put that in there. We should have, the reason why we're justified in concluding Q is because we believe P implies Q, and we also believe that if you have P and you have P implies Q, then you're justified in deducing Q. Well, of course, the tortoise points out that even with those three premises, you're still not really entitled to it. You need a fourth one that's very similar to the third one, that just conjoins the first three together and then says if you have the first three, then you're entitled to infer Q. So there's an infinite regress there, and it's a problem that has many philosophers have thought about. And it seems to me that it's related to the frame problem in that whenever we want to solve a problem, according to the symbolic approach, whenever we want to solve some problem rationally, we should choose, consider each of the various possibilities and rationally choose between them. But we must have used some basis for selecting out those, 3 or 4 or 5 different possibilities we're choosing from. So it seems that we've already applied some kind of rationality in selecting those options as the ones to consider. But there are more options to consider. So shouldn't we be first justifying the limitation to just those 5? So don't we need to think about whether or not we need to think about something else? Like, have we considered all the options? This comes up in AI as the frame problem because, when an agent, Dennett illustrated it this way: when a bomb disposing robot thinks about what will happen when it pulls a cart out of a room that a bomb is sitting on. It just thinks about whether it's going to affect the bomb going off or affect the safety of the people. It doesn't think about whether it's going to change the color of the paint on the walls of the room. And the robot doesn't consider possibilities like, well, what if I, move the cart in and out 5 times? There are certain combinations of actions and certain kinds of actions that we don't even consider when trying to solve a problem. And that action of limiting your focus seems to be one that can't be explained as the result of a symbolically engaged rational process on pain of infinite regress. Because if you did do it, then you would still have to have another symbolic rational process that explains how that process was governed and constrained in what it considered. So ultimately, I think most people who've thought about this have agreed that symbolic reasoning must be grounded in some kind of non-symbolic know-how that already contains some kind of wisdom or intelligence or whatever you want to call it, some kind of, maybe you could call it praxis, or some kind of, there's actually a better term from the Greek that I can't recall right now. Oh well, I'll have to set that aside. But there are many people who've kind of realized this point. Even an arch symbolic cognitivist like Jerry Fodor acknowledges that a rule following system must be embedded in a system that just does stuff without considering what rules to apply. And so once you make that admission, you can either then just ignore it, or you can take it seriously and say, okay, well then our artificially intelligent systems can't be exhausted by their symbolic reasoning components, but they must be built on some kind of, I don't want to call, I'll say it, foundation. There must be some kind of non-symbolic way of structuring or giving ground to that kind of those symbolic processes that make them rational in some kind of important subset of situations. So that's how the relevance problem got in there. I think the body and embodiment, there's aspects that transcend the mere transformation of symbols into symbols. That is at the very least necessary in order to prevent an infinite regress. So a disembodied system couldn't really ever get anything done. It would always be reasoning. Either it would stop being a rational system because it would just arbitrarily cut off the reasoning at some point, or it would reason about its selection of focus infinitely in a regress. So that's what I was trying to get at with that relevance problem in that paper.
Yeah. I think the what the tortoise said to the Achilles analogy really explains it really well. I invite the readers to pause the podcast and look at Wikipedia and read it through. I did that on Monday and really explained it quite well. And I think the Lewis Carroll thing was published 1893, but it's just short-term memory, so I might be wrong with that.
Oh, thanks.
So for the next question, I kind of want to warn the audience. I'm a bit of a Ludwig Wittgenstein fanboy, so a lot of the questions or maybe guests will be related to him. So the next one is, in the same footnote, you linked this relevance problem and the Tortoise said to Achilles to Ludwig Wittgenstein's idea about private language and rule following. Could you explain this link?
I'm very flattered that you've been such a assiduous student of my work to the point of looking at my footnotes and taking them seriously. Thank you. So if I can recall, I think what I was getting at with that footnote was connection to the private language arguments was something along the lines of, I mean, if you think about it, if any of you are familiar with the private language argument, I'll make some remarks for you now. If you're not, then this might not make any sense, in which case I would encourage you to do some research about that, because it's a very important contribution to philosophy. But it involves a kind of infinite regress at times as well, or at least I must admit, my understanding of Wittgenstein comes from Kripke's exegesis. So a lot of people dislike that and think that it's not really Wittgenstein, but they make this joke and call it Kripkenstein. So maybe I'm talking about Kripkenstein's private language argument. But what I mean is this, that it seems that maybe the point I'm making is just what Kripke was making there, that I didn't really add anything at all. I was just applying it to AI. That Kripke's point was that if you just having a set of rules cannot give you sufficient reason for doing something or other, because then you would need rules about how to apply those rules, and then rules about how to apply those rules about applying the first rules, etc. So those all have to be grounded in maybe this is Wittgensteinian, this term, but a way of going on. I think that's the phrase he uses, that there has to be something that's more akin to habit, which is maybe a Merleau-Ponty-esque term here, but I think it applies. I mean, a Merleau-Ponty-esque term, but I think it applies here. Just a particular non-rationally or non-symbolically rationally justifiable way of going on, but it's a way of going on that is appropriate for the circumstances. It isn't purely causal. It's not just random or just a mere matter of brute causal fact, but it might be causal, but it also has aptness or skill or insight of some kind, but it doesn't have those by virtue of being a symbolic representation, a way of taking the world to be. So that must be in place ultimately to ground the activity that is maybe best understood as a symbolic process. That's what I was getting at with that footnote or that gesture towards Wittgenstein. And I would welcome any comments back from people who are more knowledgeable about Wittgenstein as to whether or not that makes sense, or the ways in which it does or doesn't make sense, or ways in which I have understood or failed to understand Wittgenstein. But whether or not I'm accurate in understanding what Wittgenstein's view was, whatever the view that I'm creating by trying to understand Wittgenstein, I still think that's important, even if it doesn't turn out to be properly historically attributed.
I hope your email inbox won't be filled with Wittgenstein questions after this.
Well, no, that's all right. They might not. The people who send the emails might not get very good answers from me.
I think habit works. I actually got into Wittgenstein from my philosophy of science class, and we talked about Wittgenstein through Peter Winch, and he described it as habits. I'm gonna make another Wittgenstein point here. You mentioned earlier the idea of the robots diffusing the bomb and then thinking, oh, do I have to care about the color on the wall? And I guess it's linked to relevance in terms of what do you not care about? And you make this point later also with Wittgenstein, quoting him, sort of saying, if a lion could speak, we wouldn't understand it. And it links to Wittgenstein's point about form and having a similar form, or I guess similar a body or similar evolutionary needs. And then that sort of decides the relevance. So maybe some of the relevance problem comes down to evolution. And let's say if our evolution made us to diffuse bombs, then we probably wouldn't care about the color because that's not very relevant in the evolutionary process of diffusing bombs or whatever our evolutionary process is. But let's move on from Wittgenstein.
But I'll just interject to say you're perfectly right that that's the way to bring the rather abstract remarks I've been making about something that is beyond the symbolically encodable, to relate that back to the body, because that's my in this paper you've been citing of mine that quite kindly been paying attention to. That's the point I was trying to make. I was just using a notion, just saying, okay, even just a minimal notion of body as being that which goes beyond that aspect of us that goes beyond the explicitly symbolic encoded or part of us. That seems to be necessary in the ways that we've been discussing. So that's the connection, and you quite rightly brought it back to our way of life, our perceptual, our needs, our bodily needs, our perceptual systems that look for affordances that can help us achieve those needs. That all comes in because of the body, and you can take that to a greater or lesser biological extent. But thanks for closing that circle.
Awesome. All right. So next one is, I guess, looking more to the future, not to 20th century philosophy. Can current deep learning or reinforcement learning approaches solve this relevance frame problem we talked about? Or do we kind of need a different approach? Do these approaches need to be shifted towards embodiment or something else?
Yeah, so modern machine learning, it has its pros and cons, is one way of saying it, or it gives with one hand, it takes with the other, or there's good news and bad news, that kind of duality here. So the good news is that I think that the machine learning approach, the neural network approach, I basically stand by the decision I made in the late 80s to move towards a neural network approach rather than a symbolic rule following system approach, because I think that it's the kind of computational formalism that can allow, if it's done properly, it can be done in a disembodied way, but if it's done in an embodied way, it can allow for symbolic activity to emerge. I don't want to use that word maybe, but to not be built in, to not be something that is imputed into a system, but something that the system can acquire for itself on the one hand, and also destroy and reacquire in a different way again. So I think machine learning systems, because the symbolic doesn't exhaust their computational interaction with or take on the world, because there's a non-symbolic or sub-symbolic or pre-symbolic, or what I called in my PhD thesis, a non-conceptual way of engaging with the world. Because there's a non-conceptual way of engaging with the world, then a conceptual way, that is a symbolically understandable way of engaging with the world, can, of one sort or another, can be acquired or can be learned or can be justified and not just merely attributed to the system, but it can actually be constructed by the system itself. And it can be changed, modified, or dispensed with in favor of a different way, or either, again, no way, a purely non-conceptual way of engaging with the world, or an alternative, new way of conceptually engaging with the world. And I think that's more the heart of the kind of creative intelligence that we are looking for in creating systems that are intelligent in the way that we are, not just a kind of fixed algorithmic fluency or facility with a particular way of dealing with the world, but a way to arbitrarily change one's way of engaging with the world in order to deal with novel situations or a changing world. And so I think this notion of embodiment, and I think what follows from that, a kind of pre-symbolic or sub-symbolic or non-conceptual way of engaging with the world that is provided by the body, that's essential to certain kinds of intelligence, and hand in hand with that, certain kinds of creativity.
You perfectly bridged me to my next question. Non-conceptual content, what is it?
When we think about and talk about other people's mental states, let's say let's just focus on belief states. So what other people believe. We usually talk about, like, if I want to explain somebody's behavior, I'll say, Jim missed the lecture because he thought it was at 9 instead of 10, or he thought it was at 10 instead of 9. He believed that it was at 10 instead of 9. When I explain his actions, I use these things called, the beliefs, what he believed and how his beliefs relate to his desires and relate to his actions. But also, even with the beliefs, there isn't just one belief. There's different kinds of beliefs. The belief that today is Wednesday, or the belief that the lecture was at 9 or 10. So there are all these different kinds of beliefs. The way we talk about them is we use language. We give a that clause. We give a clause that starts with a that, and then we fill it in with more language. So you'd say, Jim believed that the lecture started at 10. That the lecture started at 10 that bit of language is meant to be the same contents of his belief as the content of his belief is the content of that linguistic utterance that I just make. So my statement has some content, and I'm saying that his belief had the very same content as the language that I'm giving you now. So that's the idea about what content is. It's the kinds of it's a way of understanding the significance of mental states, how they relate to each other, how they relate to the world, and the conditions under which they're true or false, and what follows from them, what doesn't. And contents or content that's specified that way is essentially linguistically shaped and structured, because I'm using language to specify it. I'm saying the same content that is the content of this sentence is also the content of his belief. Now, what if it turns out that there are contents that there isn't any statement in English that has that content? What if there are ways of taking the world to be, of believing the world to be in a particular way, and we don't have any English sentences that actually carry that same content? Well, then we can't use the that clause approach to talk about the content of those mental states. We need some other way of doing that. And so, roughly speaking, non-conceptual content is a way of taking the world to be, could be correct or incorrect, just like beliefs can be incorrect or incorrect, but it doesn't have the same linguistic structure. It isn't necessarily you can't easily break it down into having different conceptual parts like you can with the contents carried by language. Like if I believe that Mary gave the gift to John, then I have a concept of Mary, a concept of giving, a concept of a gift, a concept of John, and I can recombine these concepts in arbitrary ways. Well, maybe there are contents of human, adult human, maybe infant human or animal or machine computation or representation that aren't easily expressible in terms of concepts being recombined, concepts that are recombinable in arbitrary ways. Maybe they can't be, they don't exactly have the same kind of structure. And so at the very least, we need a new way of specifying these contents. But I think it's more than just how to represent them and talk about them. I think they actually have different generalizations are true of them. They behave in different ways, or the mental states that have those contents behave in different ways and have different connections to action and perception than conceptual contents typically do. So once you, and having given an argument for the existence of these different ways of thinking, but I hope it's intuitive when you think about how rich our experience is and how difficult it can be to put into words, or how unlikely it is that an infant is experiencing the world in the same way that we are when we say there's a cup on the table. You know, when we say or think there's a cup on the table, we're using a concept of cup that carries with it commitments to it existing when it's not being perceived, and having been manufactured, and that it's a container for liquids, et cetera, that when an infant is having an engagement with something that we would call a cup on something that we would call a table, it isn't necessarily thinking of it with those concepts. And so we maybe don't even have any concepts in English for the way the infant is thinking of those things, maybe because they actually aren't even concepts yet. So non-conceptual content is the way of engaging with the world in a way that's independent of or prior to our conceptual engagement with the world. And I think we have our conceptual engagements with the world because of a certain structuring of our non-conceptual ways of engaging with that world. And therefore, if you want the kinds of intelligence I was talking about before, that can come up with structured ways of thinking of a domain, but then can also break that down and restructure it in a new way. If you want that kind of creativity, I think you really need an AI system that has non-conceptual ways of engaging with the world. And I think machine learning can provide that. If you hook your machine learning, if you make sure that your machine learning system is embodied, that it is in a world that it's engaging with, and isn't just you don't just analyze it in terms of performing some kind of real valued mathematical function as opposed to a symbolic structured mathematical function, then I think machine learning is a way forward for having a truly non-conceptually embodied AI, but it isn't guaranteed. You can still end up having a disembodied AI system, even though you're using neural networks as your formalism.
On the two examples you mentioned, for example, Mary gives John a gift. I think there's that element of constancy that you can swap things. For example, you could say, John gives Mary a gift, and if you understand one, you probably understand the other.
If I could just add to that. So what you highlighted was a property of representations or thinking about the world called systematicity. So with conceptual ways of representing the world, concepts exhibit systematicity. And by systematicity, we mean if you're capable of representing or understanding John gave the gift to Mary, you are ipso facto, by that very same fact, able to understand Mary gave the gift to John, or the gift was given by John to Mary, or all those different combinations. Or if you have any other ways of representing people like Tom or Phil or the queen, whatever, then you could also substitute those in the proper place, and you'll understand what those sentences mean. They aren't all true necessarily, but at least you would know what it would be for them to be true if they were true. And what I'm saying is that there's a kind of way of representing the world, it seems, that isn't systematic like that doesn't have that feature of being able to, where just because you're capable of understanding that particular relationship for a few things in your repertoire, then you can therefore grasp it for any arbitrary object that you can think about. So that would mean if there's non-systematic ways of thinking of the world, that they therefore cannot be understood as being conceptual in that strict, maybe philosophical sense, or the notion that's usually assumed for concepts by at least philosophers, but I think it's for some psychologists too. So yeah, that's an example of one of the conceptual properties that I'm trying to question and say, if we build AI systems where you don't assume that, and you have some way of talking about states or processes that are representational, but you have a way of talking about representation in non-conceptual terms, then at least you can understand what the dynamics of those systems might be like, and under what situations it might converge to a more systematic kind of representational system, and when it might be able to break away from that systematic representation in order to form a new, different kind of systematic system, a systematic representational scheme, or whatever.
The world or experiences can necessarily be non-systematic, and I think on my reading list there's Maurice Morley-Ponto, whom you mentioned earlier, and I think he makes the case for that. So hopefully I can have a podcast episode on that in the future. We can talk more about that. But next on the list, linked to non-conceptual content, is your work on synthetic phenomenology. And I just have to say that sounds super cool. Can you tell us more about it?
Well, I don't need to say too much about that beyond what it's just to explain the term and relate it back to what I've just said now. So there's this funny way in which the term phenomenology is used. Sometimes it means the study of experience in a careful way. So the phenomenologists were a set of philosophers, maybe some psychologists too, who very carefully paid attention to what an experience was like and tried as much as possible to bracket off their preconceptions about what that experience would be like, or what their theory of what they were doing in that situation was, and instead just pay attention to the experience itself and document that and reason about that and think about that. So that's phenomenology. Sometimes, though, when people talk about phenomenology or use that word, they don't mean the study of experience. They just use it to refer to experience. So they'd say, does this system have phenomenology? They mean, does it have any experience? Does this system have any? A colleague of mine, I think Rob Clowes, suggested that maybe the word they should have used was phenomenality. Does the system have phenomenality? And if so, maybe we can study it using phenomenology. Okay, so when I say synthetic phenomenology, I don't mean necessarily systems that have synthetic phenomenality. That is, they're artificial, or they've been synthesized, or it's a kind of consciousness that's been synthesized. I'm very interested in that issue and about how that might or might not be possible. But when I use that term synthetic phenomenology, I mean phenomenology in the kind of nerdy, strict sense. I mean using artifacts not to create a system that has phenomenality, but to help us do phenomenology. So I said in my previous remarks that just using that clauses will be insufficient for non-conceptual content, because that clauses can only specify contents that are linguistically structured and conceptually structured, perhaps. Well, if we're going to then instead refer to and theorize about specified contents that are not linguistically structured or linguistically specifiable, how do we do it? Well, in my writings on synthetic phenomenology, I've suggested that maybe we can get technology to assist us to refer to experiential states in a canonical, that is reliably scientific way, that's referred to them in ways that really get at their essential nature, without trying to find some language that has the same content, but instead, just using maybe virtual reality systems, or using artificial intelligence systems that we're familiar with, in order to be the way of specifying the content. So if I might try to, for example, talk about a non-conceptual content that an infant has, I could say the infant has this non-conceptual content. When I say this, I actually give to you a specification of robotic capabilities, a state of a canonical AI system that we are both familiar with, and how it's situated in an environment. Or I might do it in a more direct way, where I say, load these parameters up in this VR system, go in there, experience the experience of being in that system under those conditions and parameters. And that's akin to the experience that I'm attributing to the infant in this experimental situation. So I could directly use your embodiment. I could, what's the word I'm trying to exploit your embodied experiential activity in order to specify to you the experience, the experience I have in mind, or the content I have in mind that the infant is having in this scientific situation I want to describe to you. So I explored in my thesis and in some other writings some different ways that we could use technology to get around the limitations of a simple that clause approach to specifying content.
To work with synthetic phenomenology, you also created a robot, and it's quite interesting. You put that robot in an art gallery, and I think that really bridges to the next topic, which is your work on AI creativity. So what are you doing to achieve creative AI?
Well, if there was a connection between AI and creativity in that situation you mentioned, that was work done with a student of mine, Joel Parthmore, where we were trying to do this synthetic phenomenology by using a particular robot. We had this theory of visual experience. In a way, it was a precursor to the predictive coding models. Now, only applying it to experiential content. We were saying that maybe one way to understand what, say, visual experience is a set of expectations about what inputs one is going to have. I don't mean that you as a subject have those expectations, but you have a visual experience of a certain sort by virtue of your brain having certain kinds of expectations about what inputs it's going to receive if you were to move your head or eyes this way or that. And that set of expectations determines the non-conceptual content of your visual experience. And so the way to specify that to you would be to just actually display, it's maybe on a monitor, somehow display to you what the set of expectations the robot has. And if you do it the right way, there's an intuitive way where you can then say, oh, right, I understand now what experience the robot is modeling, because I have this non-linguistically specified content in front of me. So we were doing that scientific work, and then it turned out that some of those images had an aesthetic appeal to them, at least to us. And so we thought others might like that. And so we had we had an installation actually it was a competition in Shrewsbury. And some of the images it produced are themselves interesting, but also some aspects of the installation in the gallery were interesting too. So maybe that exhibited some creativity that was aesthetically interesting. But more directly, I'm interested in understanding how we can make AI systems that are themselves creative in some sense, or more creative at least than the current ones. And so that system that in that gallery was not in any way creative itself. But this work is more speculative in that I have published some papers sketching out some aspects of these ideas. But as far as building working implementations of these ideas, some of my students have done this, but I haven't really done it in a full-bodied way yet. So it's still work in progress. But the general idea I can talk about very briefly. The idea is that if you have a set of certain constraints in place, it seems to me you're likely to get an AI system that is likely to be very creative, and that is going to generate novel outputs of value or of interest. So what are these different elements? Well, one way of thinking about it is like thinking of it in a way similar to, again, architecture, which is a generative adversarial network, which has two components. One thing kind of generates things, and the other thing tries to classify those outputs in a way, and they compete between each other. The generator tries to create things that the classifier can't classify and things like that. So my idea is similar to that, but it's not quite that. So the idea is that you might have two networks. One is an appreciator network. So it experiences or receives inputs that it has a positive or negative reaction to. And what determines whether it's going to have a positive or a negative reaction to it? Well, you could build in lots of things. Like if it were a music system we're talking about, you could build in a preference for certain kinds of intervals or certain kinds of melodic structures or whatever. But that's not what I want to talk about. What I want to talk about is a kind of a domain independent constraint you could build into its preferences that under certain conditions might trigger this runaway creative process between these two halves of these systems. I haven't described the other half yet, but it's the generator. So the idea, it might be this, that let's say you have the evaluator, the appreciator, preferring inputs that it can understand or predict or compress, but with this extra qualification, if that understanding or prediction or compression is achieved without much effort, then that low effort kind of kills the value for it, the interestingness for it. So the idea is it has to be a kind of maybe a multiplication between the amount of compression it's able to do on a particular set of inputs, or the successful amount it's able to predict a sequence of inputs coming into it, but you multiply that by the amount of effort that it took, so that if it took zero effort or near zero effort, then it's going to be near zero appreciation or valuing of that input. But if it took a lot of effort, but it was still able to get that understanding, then you'll have a maximal score. So if you have something that just cannot be predicted or cannot be, by this system, cannot be compressed or cannot be understood, then you're going to get a low score on that side. Even though you spent a lot of effort, still you didn't get very good results out of it. So that's going to be a near zero. That's going to be low, not appreciated very much. But and similarly, if it's a easy to compress signal, then like in a melody, something like the childish na 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 na, that wouldn't take much of a system to be able to compress an arbitrary, like 1 minute of that annoying minor third. It wouldn't take much in computational terms to be able to compress that or predict what's going to happen next. But because it's so easy to predict that, at least after maybe the first few times of hearing it, then you'll get it's not rated as a very interesting input. So here's the other piece. You have a generator that's trying to please the evaluator. It's trying to generate strings that the evaluator rates highly, but it also takes into account the fact that, there's one other piece, that the evaluator, when it recognizes or compresses or predicts something, it's built in such a way that it becomes easier for it to do that same compression or evaluation or prediction in the future. So now if the generator wants to generate something that pleases the evaluator, then maybe initially a minor third alternation like that would work, because maybe that system had never experienced it before, so it takes a little bit of effort. And it's able to predict it and compress it without much effort. But it takes some effort, so it gets a moderate score. But now the generator, if it wants to continue to get positive feedback from the evaluator, that is, give the evaluator something that it likes, then it needs to up its game. It needs to generate something that's different, that will now be, given that the evaluator has improved, now the frontier of what is on the cusp between understandable but difficult versus not understandable at all, that horizon has moved. So the generator needs to change itself and create a new kind of input to the evaluator that will still be understandable for that new state of the evaluator, but will also still be a challenge for that new state of the evaluator. So the generator has to change and improve itself. And then you get this runaway positive feedback situation where the generator will, hopefully will come up with that. And then the evaluator will be, you get a positive result, but the evaluator will therefore change. And that thing which was positively evaluated before now won't be positively evaluated because it's too easy to understand, and so you'll have to have a constantly changing process here. And that there are some very strong similarities between what I'm talking about here and the work of Jürgen Schmidhuber. came at this idea independently of Jürgen, but he has done a lot of really, really good work on the something very similar to my idea. So he's really somebody that if anybody's interested in this, you should look at his work, not mine. I don't really have anything of interest yet compared to him. So that's there's a strong affinity there, but I think this is a very general notion that could be useful in all kinds of situations, not just creating interesting melodies or music or artworks, but also designing functional, practical things, adding an aesthetic component like this, or this kind of the edge of chaos idea that it has to be something that's understandable, but only just. That could lead to all kinds of, adding that factor into generative processes can lead to all kinds of innovations. For example, the designing of curricula. So if you want to teach a student, it might be a good idea to have an idea of their edge of chaos. What's a problem I can give them that they can solve, but only if they expend a certain amount of effort. And if I have a good model of what their capabilities are, but also a good model of what they find difficult and what they don't, then I can maybe hit this sweet spot where they get maximal satisfaction from solving that problem. And it isn't just solving problems, but maybe appreciating artworks or interpreting passages of text or whatever. So I think it's an idea that could potentially have value far beyond just the designing of artificially creative systems.
Last time we talked about these questions, I asked you how effort is operationalized, and I found your answers really interesting. Could you share them to the listeners?
Yeah, so I like couching in this general term effort so that it could have different potential realizations, but it has to be something that isn't, it has to, well, let me just give some examples of what it might be, and then maybe that will help explain the general concept. So maybe it's the absolute amount of time spent by the process in coming up with the compression or understanding or prediction, or it could be the amount of energy required, or in the case of let's say a machine learning system, it could be that it might be that here's an idea that one of my students and I were testing out, is that you maybe could measure the distance that the network has to move in a certain space, like how much it has to change its weights in order to accommodate the new input and yet keep the old understanding of the old inputs that it's experienced. If there's a measure of how much it has to change in order to perform that balancing act, doing that right, then that could be a measure of effort, or it could be how much time it takes to find that, or it could be the number of computational resources that are involved in finding that. Yeah, I leave this open because I think it really is a general, it really does depend on the implementation. And I don't think that makes it a vacuous notion. I still think there's a kind of, there's a constraint there that as long as it's relatively independent from the criteria for what it means to compress or what it means to succeed at predicting or understanding, as long as there's some independence there, then it will be a kind of a constraint on the understanding process that could have this beneficial effect I mentioned. If it's somehow entirely understandable as just a reformulation of compression or prediction or understanding, then it's not going to have that. It's not going to change it's not going to be an external constraint in any way or additional constraint in any way. So there is that minimal requirement that it be at least partially independent from how you measure success at understanding the input that's coming in. But as long as you have that, then I think, and it's somehow related to limited resources, and then I think you could have this kind of a beneficial runaway process emerging.
Do you think there's a parallel between the change in weight space to neuroscience with like Hebbian learning and the kind of requirements for synaptic plasticity to occur? Because I guess that's also, you could measure what do you need for synapses to like rewire or something like that.
Yeah, I'm going to say that I'm going to step back here and say I don't know neuroscience well enough to make any speculations along that line, although I have been heartened to find that there are some neuroscientists who seem to have some basic notion of this idea of it not just being a matter of succeeding, but also a matter of some kind of effort that's required in order to achieve the success. there seems to be some preliminary studies, but I don't. My neuroscientific expertise isn't good enough for me to say anything, I think, intelligible enough or authoritative enough to share on this podcast.
If there are any listeners out there who specialize in neuroscience, I'm always looking for guests. So maybe we can talk about that in a different episode. Now I've got a sort of a different question, but I think it's really important for listeners around my age. I'm 22, or maybe people a bit older. What career advice would you give someone interested in AI and philosophy and sort of follow your foot tracks or achieve similar remarkable outcomes? What would you recommend them to do?
Yeah, that's a great question. It's difficult for me because I want to use my own experience to give me something informed to say on this issue. But I also am aware that maybe my particular path is so unusual that it might be silly to expect someone else to get good results by following it. And I was so fortunate that things worked out in a particular way that I might not want to recommend somebody to try and copy it because it might be not a very reliable path. But the good news is that I think now is an amazing time to be interested in this particular intersection of issues. And although I think going the academic route was essential for me to get where I am, and I have no regrets about doing that, there might be ways, you kind of think, when I was just starting out, there wasn't an internet to speak of. So, maybe there was more of a necessity for gatekeepers and for guided programs and, doing things a particular way through the university system. Maybe now there is an option for people to be actually working in a practical way with AI as part of their employment, but also somehow learning about the philosophical issues and the deeper theoretical issues independently of that or in conjunction with that. So all I can say is that I think that the possibilities for exploring these issues are so much greater than they were when I started out. So that's got to be a great thing. It's got to be a great time to do this. The ways that you can combine them with academic or industrial study are also much greater than they were when I started out. All I would say is that I was specifically advised by some people to not study the philosophy first, at least. So when I was thinking about what to do as a graduate student, I don't want to name any names, but there was at least one faculty member at Stanford who really tried to dissuade me from studying philosophy. And in my particular case, I'm glad that I ignored that person. So all I'm saying is make sure that you leave, if you want to look at the kind of intersection of issues that I've looked at, then you need to make sure that you leave time for serious philosophical study somehow. And philosophy has to be done well and thoroughly to be of value. So I remember this point being driven home to me by Brian Cantwell Smith when I was considering what I was going to do, and I was telling him that I was, this is while I was working at Xerox with him, and then I decided I was going to go to Oxford. He warned me that if you focus on philosophy, then you really have to do it well in order for it to be of a contribution to these back to AI. But if you do philosophy and you don't really do it well, then it can be a distraction or worse. So I think there's a risk of just doing philosophy, your engagement with philosophy to be just kind of reading what people say in blog posts on the internet or listening to podcasts. That will limit seriously your depth of understanding and the value of the philosophy. It really only becomes of true value, or its greatest payoff comes when you actually engage with it yourself and you read the extended, very dry sometimes arguments and engage with them and try to criticize them and construct your own counter arguments and expose those to criticism from others in a systematic way, a disciplined way, not the kind of way that's sometimes happens in discussions on the internet. So I would just say that if you're going to try to incorporate the philosophical aspect, then try to do it in that way as much as possible, even if it isn't in a officially sanctioned philosophy program. Try to emulate a lot of the aspects of the best philosophy programs, which involve those features that I mentioned to you.
Yeah, I'll make sure to keep texts and papers and books we talk about in the description of each episode, so you can go out and read on. And final question, and this is quite a big one. So it has been 20 years since you published the article on Embodied AI. Where are we now with Embodied AI, and where will we be in 20 years?
Wow. So I don't know if I'm very good at predicting the future in this way, or getting out a crystal ball, or I'm not a great futurologist, but it seems to me that finally we can build some of these sophisticated embodied AI systems that it was not possible to do so in the past. So in two ways. One is just robotic systems are going to be, the kind we can have really good AI systems grounded in actual robotic systems that are engaging with the world and are learning about the world from an embodied perspective, and therefore more likely to acquire the kinds of concepts that we use in our thinking, because that's how we got ours, either through our own lifetime or through our evolutionary history. We acquired certain concepts that are good for dealing with space-time and with coordination of perception and action in particular ways. So if we build AI systems that are learning, but learning from that perspective, then it's more likely for them to be the kinds of things that we can recognize as intelligent. They're more likely for them to represent the world in a similar way as we do, and therefore more likely to be able to present themselves to us more likely to understand what we're really about, and more likely to, whether they're intelligent or truly conscious or intelligent or not, they'll be able to fake it in a very, very serious way, because they'll have a similar starting point, building blocks, or constructed things out of the non-conceptual building blocks. But also, and this isn't just because it's a trend right now, like Facebook and Meta, but I think virtual embodiment is, on my view, a real possibility. It's not an oxymoron. So you could have an embodied system that is purely virtual, as long as there is some notion of perception, a locus where perception and action takes place. Even if it's a locus in a virtual space, it's still, that might be enough for embodiment to get a grip, and therefore the benefits that I just mentioned before about mutual intelligibility to apply. So I think we're now in the next 20 years, we're going to see systems that are much more deserving of the term embodied AI than ever before. And I think that's where the action is going to be. I think we talk about limitations to current approaches to AI and the deep learning approach. I think one serious contender for how that impasse can be overcome is for the AI systems to be embodied either virtually or in the actual world via robotics. And just as a way of winding things up, and in preparation for your future guests, I just want to say that I hope I've made it clear that it's possible to value embodiment in AI without either being anti-symbolist. So I'm not saying that embodied systems don't use symbols. I just think that the symbols have to be grounded in a kind of, or constructed out of a sub-symbolic, pre-symbolic kind of embodied substrate first. But even more obviously, it should be even more clear that I also don't think that to be an embodied AI researcher means you are you're taking an anti-representational approach. So some embodiment theorists might say that the only way forward is that the notion of representation, internal representations, that they're either incoherent, or they get in the way, or they're not important to intelligence. And yet I think representations are important, but there's a way to have embodied representation, and that's really the way forward.
This has been great. Thanks for taking the time, Ron.
Well, thank you for taking the time, and thanks for doing your such extensive homework. It's flattering to have someone pay attention to one's work with the care that you have and the depth that you have. And also, thanks for giving me this pride of place as your first episode ever of this podcast, which I hope turns out to be a very successful one.
Thank you. I hope you enjoyed this episode. If you want to stay updated when the next episode is coming out, please follow the Twitter or LinkedIn account in the description. I aim to publish at least one episode every month. Have a nice day.